Hi, my name's Megan, and I'm going to present my final project, which I like to call the Arthropod Weatherman, where I look at the influence of climate variables on insect abundance. So climate directly affects insects by limiting their growth and reproduction. So for example, these are just some of the responses of insects to increases in temperatures. So it's really important for us to have a good understanding of geospecific responses of insects to local weather. And so that's what I wanted to do in this project. To do this, I found insect data from the University of Copenhagen Zoological Museum. So they collected insect abundance data for two different orders, Coleoptera and Lepidoptera, between the years of 1992 and 2009. And they collected these insects in a Robinson light trap, like what's shown here. For the purposes of this presentation, though, I'm just going to be looking at the beetles that were collected. So to look at the influence of climate variables on these insect abundance values, I collected temperature and precipitation data from Climate EU. I gathered this data as monthly average values, and then I was going to compare it to the Copenhagen data. So here is a plot of insect count as a function of temperature deviation, where temperature deviation was calculated as the difference between a monthly value and the overall average monthly value. So there's a separate point for each family in each month of the 18 years of data. So we can see that the summer months of June, July, August seem to have the most visible relationship between insect abundance and temperature, which I'm going to quantify later. And then here's a similar graph for precipitation, where precipitation deviation was calculated as a percent value of the monthly precipitation compared to the overall average precipitation value. So for example, 0% would be no precipitation, 100% would be right on average precipitation amounts, and 200% would be 2 times the average precipitation. So again, it seems that the summer months of June, July, and August seem to have the most visible relationship between precipitation and insect abundance, but this might just be due to the scale of these graphs. So let's quantify the relationships between climate variables and insect abundance. To quantify these relationships, I use the non-parametric Kendall's correlation coefficient. So I calculated a coefficient for each individual month of the entire data set. These are these red points. And then I used bootstrapping methods to resample the entire data set to create a distribution of correlation coefficients from that resampled data. And then I used this distribution to create 95% confidence intervals for the original Kendall's correlation coefficients. So those are these blue lines. Essentially, you'd get a graph with the y-axis being correlation coefficients, the x-axis being your categorical variable. And if your confidence intervals did not cross the imaginary 0 line, then it would be a significant relationship. But if the confidence intervals cross that 0 line, it would be an insignificant relationship. So here are the final results. This is precipitation correlation coefficients by month, and then temperature correlation coefficients by month. If the confidence intervals are dotted, it means they are insignificant, and if they are solid, it means they are significant. So what we see is that concerning precipitation and insect abundance, there's a positive relationship in June and negative relationships in July and November. And then concerning temperature and insect abundance, there's significant positive relationships in the summer months of May to August, and also a positive relationship in November. What's important to note, though, is all of these correlation coefficients are of a small absolute value, so these aren't very strong correlations between the two variables. So the final conclusions concerning the temperature data, it would seem that insect abundance is higher when the summers were warmer, and that there's a potential influence of warmer Novembers on higher insect abundances. And so these trends can be explained by physiological optimums. So because temperature directly influences growth and reproduction of insects, it would make sense that warmer temperatures would have higher abundance values, but also the timing of highest insect activity. So the summer months are when you see the most insects. It's also usually their breeding season. So that would just compound those abundance values in those months. And then concerning precipitation, it was seen that a wet June followed by a dry July would result in the highest insect abundances, and that there's also a potential influence of drier Novembers with higher insect abundances. So these don't really have any clear conclusions. And I think the lack of more conclusive precipitation trends are potentially explained by masking by other variables within the city. So maybe Copenhagen is just a really optimal habitat for insects. And so you're not going to see the same amount of responses to climate as you would see somewhere else in the world. Most importantly, is that the results gathered information to better understand climate effects on insect communities, but they have no socioeconomic implications at the scale of my analyses. So because I didn't split the insects into their functional roles, I can't make conclusions like this is going to be bad for agriculture or this is going to be good for forestry. I'm just contributing to the growing knowledge of insect trends to changing climate. So thank you for listening. If you're interested, please visit my website. I also do the same analyses for moths and butterflies, and all my contact info is on that site if you want to contact me with questions. Thank you so much.